picture that goes over a few of those. There's a few other reasons. Interesting, unborn babies actually have a different type of hemoglobin protein that holds oxygen. It's called fetal hemoglobin. And fetal hemoglobin actually has a higher affinity for binding oxygen. It likes oxygen, to hold on to oxygen better than adult hemoglobin. So they should have a higher oxygen carrying capacity. And this ensures that the movement of oxygen is very good from mother to infant through the placenta. Not infant yet, but soon to be. Infants, there's my infant word. Because of this, when a baby is born, sometimes they become jaundiced or yellowish in color. And this is due to the slow rate of the breakdown of fetal hemoglobin. Jaundice is our word here. Jaundice. When hemoglobin breaks down and is eliminated, it gives off a byproduct called bilirubin, which is a yellowish color. So if it doesn't break down at the proper rate, it causes yellowish tinge. Okay, so next, the last few things after hemoglobin and after oxygen carrying capacity and after how carbon dioxide travels in the blood, we're going to talk about other factors, things related to breathing. Hyperventilation is when your breathing rate or depth is above the body's demand. A few things can cause hyperventilation. Anxiety, going up too high in altitude, or it can be voluntarily caused. Like some kids will hyperventilate on purpose to get their parents' attention, for example. What happens during hyperventilation, and this is important, the partial pressure of oxygen, and I'm not going to be able to subscript to that. That should be PO2, and that little 2 should be little. Because you are exhaling so much, it's going to increase the oxygen, and so PO2 rises and PCO2 falls because you're exhaling so much. So it causes not enough carbon dioxide. And remember, breathing is stimulated mainly from partial pressure of carbon dioxide. So, and this is called hypocapnia. And you can't get more oxygen because your blood is still saturated. And that's the danger there. Because of the low blood CO2, it causes vasoconstriction of the blood vessels. And that constriction can decrease oxygen delivery to the brain. Okay? And because there's not enough carbon dioxide, that means there's not enough hydrogen ions. So actually, it can cause something called respiratory alkalosis. It's too basic in the blood. And hyperventilation can make you dizzy, numb, make tingling happen, cramps, tetany where your muscles fuse, get rigid. If it's prolonged, if you don't slow down the breathing, it can cause disorientation, loss of consciousness, possible coma, and even death. So should be taken quite seriously. Hypoventilation is the opposite of that, breathing too slow, bradypnea, or too shallow. Not deep enough breaths, hypopnea. I probably didn't demonstrate that very well, but you're not intaking as much air with each breath. Things that can cause it when the airway gets obstructed somehow, maybe something's lodged there, pneumonia, a brainstem injury, other things in the respiratory system. It's the opposite problem is hyperventilation. In this one, the PO2 level's down, so you don't have enough oxygen, and CO2 levels up. CO2. Okay. So it can lead to hypoxia, not having enough oxygen in your tissues. And it can lead to too much carbon dioxide, hypercapnia. So not enough oxygen in hypoventilation, too much carbon dioxide. So it may result in increased hydrogen ions because remember when hydrogen ions or carbon dioxide is being carried in the blood, it also releases hydrogen ions. So too much carbon dioxide, too much hydrogen, meaning your blood could be too acidic. It's called respiratory acidosis. Danger here, lethargy, I'm tired, sleepiness, headache, polycythemia, which is too many red blood cells, cyanotic tissues, bluish, prolonged, convulsions, loss of consciousness, death. Breathing and exercise. So when you're breathing, you know that your cells need more oxygen. So when you're exercising, breathing shows hyperpenia to meet tissue needs. But the rate remains the same in exercise, the rate how fast you're breathing, but the depth increases the more air you're getting with each breath. Because you don't want to be hyperventilating when you're exercising. You just want to get more oxygen in with each breath. So that would be the depth of the breath. Interesting enough, even when you're exercising, the oxygen going in and carbon dioxide going out are level. They're equal, relatively constant. So why it happens, people really don't know because there's no real trigger from the respiratory gases. Some people believe it's due to the joints communicating with the brain in response to movement. That's proprioceptive communication. Some people think it's the cerebral cortex, and then just the conscious anticipation of exercise, stimulating the breathing or the deeper breaths. So I believe that's the end. Yes. All right. So that is the last part of chapter 23.